Hey there, in this video we're going to take a look at simplifying quadratic expressions into standard form. So we are going to do a quick review of what standard form is. So remember that standard form for a quadratic expression is going to be written in this format down here. So we have three terms. Sometimes we're missing a term, but the key thing with standard form is that it starts with the highest exponent, which in a quadratic expression is the squared on the x. Then it goes to the x term, which technically has an exponent of 1. And then the c is the constant on its own. So we have our a, which is our coefficient on the x squared, our b is the coefficient on the x, and then our c is our constant that is by itself. And it will always go the squared exponent, the 2, that goes first, and then the x with the first power goes second, and then the constant last. So looking at some examples, we are first going to start with number 1. You'll notice that number 1 does not have any parentheses. It does have exponents. It has multiple terms, but there are no parentheses here like 2, 3, and 4, just as a note. So looking at number 1, we want to look or think about our order of operations. So please excuse my dear Aunt Sally. And we see here that we have negative 5x plus 60 minus 3x squared plus 3x. So looking at that, we have no parentheses. The only exponent we have is not able to be simplified because the base is a variable. So x squared can't be simplified any further. And then we have multiplication and division. For multiplication and division, other than the coefficient and the x, or the coefficient and the x squared, there is no multiplication or division going on here, so there's nothing that we can actually simplify. And that leaves us with addition or subtraction. So with addition or subtraction, that's basically our combining like terms. So we can see left to right, we see negative 5x plus 3x. Those are going to be our like terms here because they are both just an x term. And then we also have our constant. There's nothing that's able to be combined with our constant. And then we have negative 3x squared, which again does not have any like terms because there's not another squared term, x squared term. So let's start with negative 5x plus 3x. Negative 5 plus 3 is negative 2, so negative 2x. We still have plus 60, and we still have minus 3x squared. At that point, we ask ourselves, is everything added or subtracted? Yes, nothing else can be combined, but it's not quite in standard form yet, because it's not listed from highest exponent to least highest exponent. So negative 3x squared minus 2x plus 60 is how we would rewrite that. And the way that I did that was I started with what is my highest exponent on any of the terms, and that would be the squared, so that's going to go first. Then I look at the remaining two and I see that this one has technically an exponent of 1 on that x. So that's the second highest exponent. So that's going to be the second term. And then our constant, which does not have a variable, is always going to be our last term or our third term here in a quadratic expression. So our final answer in standard form is negative 3x squared minus 2x plus 60. And then on number 2, we have a similar expression in the sense that we are going to be simplifying it from a non-standard form version to a standard form version, but otherwise there's a lot of differences here. So we see that we're still going to follow the same order of operations. Please excuse my dear Aunt Sally. Parentheses, there are parentheses this time, but within the parentheses there is no combining or simplifying that we can do, so that step is done. But there is an exponent that isn't just sitting on a variable. So this squared is on x minus 1. So we do need to go ahead and write that out twice to square the x minus 1. So just as a reminder or just a reference to understand what we're doing here, 3 squared, for example, is really 3 times 3. Or 9 squared is really 9 times 9. Or x squared is really x times x. So if we have x minus 1 squared, what that really is x minus 1 times itself, x minus 1. So that's what we need to do here. We need to go ahead and write this out twice so that we can go ahead and multiply those two sets of parentheses together. X minus 1 squared, it breaks into x minus 1 and x minus 1 getting multiplied together, and then we still have this minus 5 that will get tacked on to the end, but we won't be able to do anything with that quite yet. So x minus 1 times x minus 1, we go ahead and distribute. X times x is x squared. X times negative 1 is negative x, or negative 1x. Negative 1 times x is negative x, or again, negative 1x. You can put the ones there or not. Either way is fine. And then negative 1 times negative 1 is positive 1. And we do still have this minus 5 that just gets carried down for now. So that covered the exponent. That operation really did multiplication and division as well here, just by simplifying that exponent. And there is no other multiplication or division. So then we come down to our addition and subtraction, which is just our combining like terms. So when we're combining like terms, we see x squared is the only squared term. Minus x and minus x get combined because they are both x terms. And then plus 1 minus 5 get combined because those are both constants. So when we do that, we have x squared still. Negative x minus x, or negative 1 minus 1, is negative 2x. Notice the x does not become x squared when you're combining like terms. Remember, it just stays the same. And then 1 minus 5 is negative 4. This is in standard form because the highest exponent is the squared, then the x, then the constant. So this is our answer on number 2. Looking at number 3, again, we have a different setup at the start, but we're still going to follow those same steps to get this into standard form. Parentheses, we don't have anything within either parenthesis that can actually be simplified. So within x plus 5, nothing can be combined. Within 3x minus 4, nothing can be combined. So parentheses are done. There are no exponents at all in this one, so that's done. Now there is multiplication and division here. So we have distributing these two sets of parentheses. That would be my suggestion as to what you're going to do first here. Now technically there are many options. This 2 that's right here out front, it is a factor that's being multiplied by x plus 5, and that's being multiplied by 3x minus 4. So there are 3 factors here. There's the 2, the x plus 5, and the 3x minus 4. So technically, you could multiply any 2 of those to start. But one of the biggest mistakes that I see people do is they will multiply this 2 by every term after it. And that's not what is being done here. So the 2, if you are going to multiply the 2 first, I would suggest you do it to, for example, this one, the x plus 5. And if you're going to go that route, I just want to point out why I wouldn't. But if you were, you'll get the same answer in the end. But you'll notice if I multiply that 2 in now, I would get 2x plus 10 here. And then I would have to multiply it by that 3x minus 4. So I'd have to do distributing. But if I'm distributing with that, I'm working with a bigger set of numbers, 2 and 10, instead of 1 and 5, to multiply by that 3x minus 4. So I would personally wait to distribute that 2 until after you do the 2 sets of parentheses in this one. Again, I want to make it clear you don't have to do that, but that would be my suggestion. So x times 3x is going to be 3x squared. X times negative 4 is negative 4x. 5 times 3x is 15x, and 5 times negative 4 is negative 20. So that is what we get when we multiply these 2 factors together. We still have the 2 out front, which I'll get to in a minute. Before I multiply that 2 in, I would go ahead and combine like terms inside the parentheses. You can see that in the parentheses, we do have like terms with the x's here in the middle. 3x squared does not have a like term with anything else, and minus 20 doesn't have a like term with anything else. So I'm going to leave the 2 out front, and then 3x squared stays. Minus 4x plus 15x becomes plus 11x, and then we still have minus 20. Now that I've done everything in the parentheses to multiply and divide from the beginning there, and I did any simplifying that followed in the parentheses from that, now I can go ahead and look back and see if there's any other multiplication and division. And we do see that 2 can get multiplied through all the way before we technically move on to that addition and subtraction. So 2 times 3x squared is going to be 6x squared. 2 times 11x is going to be 22x. And 2 times negative 20 is negative 40. And then finally, addition and subtraction. On this one, there actually is no addition or subtraction that can be done because they're already combined as much as possible. Technically, I want to point out, if you had multiplied this 2 through here, that would be okay as well, but then you just have to make sure you combine like terms after that step. Whereas we did it first and then multiplied the 2 in, just because it was fewer steps of multiplying if you combine like terms first. All right, and then ask yourself, is it in standard form? Yes, it's got x squared first, then x, then the constant, so it is in standard form. So that would be your answer on number 3. On number 4, you'll see that it's a little more complicated. With number 4, we have 1 minus 2x squared minus 3x squared plus 1, but we're still going to follow the same steps. So 1 minus 2x squared minus 3x squared plus 1. There is a set of parentheses, one single set of parentheses, but it doesn't have anything that can be simplified in it. 1 minus 2x, none of that is a like term with each other. So we're good to go there. Then we look at exponents. There are many exponents. We have 1 minus 2x that's being raised to the second power. And we also have this minus 3x squared. But that minus 3x squared, really the squared is just on the x. So there's not really anything we can do with the exponent on that one. So then we look at 1 minus 2x squared. And with that, we do have a binomial, or in other words, 2 terms here being squared, a 1 minus 2x together. So with that, we want to go ahead and write that out twice like we did on the problem above it. 1 minus 2x times 1 minus 2x, and we still have minus 3x squared plus 1. So we go ahead and distribute 1 times 1. 1 times negative 2x times 1, and negative 2x times negative 2x. So 1 times 1 is 1. 1 times negative 2x is negative 2x. Negative 2x times 1 is negative 2x. And negative 2x times negative 2x is positive 4x squared. And then we bring down our other 2 terms that we still have, minus 3x squared plus 1. At that point, we want to go ahead and ask ourselves, with that next step, multiplication and division, are there any steps of multiplying or dividing we haven't done? We did multiply with the exponent piece, but there is nothing else that we can multiply or divide. So then we move on to our addition and subtraction. So we're combining like terms here. So we've got 1, our constant, that can be combined with 1 over here. Then we have minus 2x minus 2x. Those are like terms. And we have 4x squared minus 3x squared. 1 plus 1, when we combine those together, we get 2. Minus 2x, or negative 2x minus 2x, gives us negative 4x. And then 4x squared minus 3x squared is going to be positive x squared, or plus 1x squared, either way. And then when we ask ourselves, is this in standard form? It is simplified all the way, but it's not in standard form yet. We need to go ahead and put this term first. So x squared, or 1x squared, goes first because it is the highest exponent of the 3. Then we have minus 4x. Notice that minus sign comes with the 4x. Whatever sign is in front of the term moves with the term. And then we have 2, so that's going to be plus 2. So that would be our final answer on number 4 in standard form. So in summary, we distribute our parentheses as applicable, and then we move on to our exponents. Once we have our exponents, then we move on to multiplication and division, and then addition and subtraction. So our biggest ones that we saw were really the exponents that come with either writing the set of parentheses twice and distributing, or maybe it's even already written out twice and distributing with that multiplication. And then we have our addition and subtraction. That's our second big one, which is combining like terms. So combining like terms, remember, you want to look for those like terms, merge them together. But when you merge, for example, 2x plus 3x, we just add the coefficients in front. 2 plus 3 is 5, and the x stays the same. So it's a big mistake that's often seen. It does not become 5x squared when you're adding those like terms. All right, and then make sure it's in standard form, highest exponent of squared first, next highest of the first power, and then the constant at the very end.